Hello guys, welcome to the video. Today we're gonna learn about the step response of a DC motor using PID controller. So I have a Matlab code for this and I have uploaded this in the description. Please check that out. Now coming to the Matlab code, so I'll be explaining part by part. So first we initialize the DC motor parameters like moment of inertia, damping ratio, motor constant and electric resistance and inductance. Then we define the transfer function for DC motors using the TF function. Then also we have to define the PID controller. So here if you give only KP, it will be a proportional controller. If you give KP, KI and KD, it will become a PID controller. We use a feedback function to create the transfer function for the PID controller. Coming to the step response, we use a step function to create the step response of a dynamic system. So now how do we tune this one? So yes, KP, KI and KD is what we are going to tune. So what does this basically do? The proportional gain KP, so it increases the response speed. So if the response speed is too slow, we have to increase the KP, or if it overshoots, we have to reduce the KP. So coming to the KI, that is the integral gain. So if the errors keep accumulating and that results into the target point never being achieved, in that case we have to increase the integral gain. And if the integral gain is too high, the response might be slow or there can be oscillations. Coming to the derivative gain, it improves the stability and reduces the overshoot. So if it overshoots, we can also increase the KD as well instead of reducing the KP. Let's check it out. So I'm keeping the KP, KI and KD as shown, and let's plot the graph and see how it looks. So we have an overshoot, also it's slow, and also the target is not achieved. So what do? We have to increase the KP because we need the response to be we need to increase the KP here now because we need the response to be a bit more quick, but it's already overshooting a bit, so we need to increase the KD as well, and also we need to increase the KI. So let's give it an 80 and let's give it 100, and here let's give it a 10. Now we have a better graph, a better smooth, and yeah, it has also achieved the target. Now for you guys, I will just increase the KP so much and let's see what happens. Yeah, you can see that there is an overshoot, and also the target is not accurately achieved. So that is what tuning the KP, K and KD does to a step response. And a step response is really an important thing when we have to design and incorporate many systems, many actuators in a control system. So I have provided a link of a YouTube video which explains about the step response. I have provided that in my description. Please go through it if you guys are interested in learning more about step response. And yeah, thank you.